Hello everyone, welcome back for the last session on in this last session. So we are going to solve some problems related to the complex power. So let us look at the problem statement. So the statement is like this: the sequence component of three-phase voltages. So the sequence component voltage are given in terms of positive sequence, negative sequence and zero sequence respectively, and the line currents are given in terms of positive, negative and zero sequence. So here we need to determine what three-phase power in kVA and as well as in per unit, having a base value. If base value is of what 1 kVA, so we need to first determine the power and in terms of per unit by using this base power value. So as we know, this is the three-phase complex power equation is given by this entire equation. So respectively the zero sequence component voltage, zero sequence component current, and positive voltage and negative voltage. So respectively we are going to substitute the each component voltage and current value in the below equation. Okay, so now let us first substitute the value of positive sequence component. So the positive sequence component voltage is how much? 200 at an angle 30 degree into the positive sequence current is given as how much? 20 at an angle 10 degree, but we want in terms of conjugate, right? So for that reason, the given in the given statement, so whatever the angle is there, right, so you need to take reciprocal of that. So here it is having an angle positive, so opposite of that is negative, so the conjugate of current will change over here. So 20 at an angle minus 10 degree plus then next the voltage meant for the negative sequence. So what is the negative sequence voltage is given 60 at an angle 60 degree into the negative sequence current, that is 5 at an angle 20 degree, but we want in terms of conjugate, right? So conjugate means we are going to change the angles sign. So here it is positive sign, we are going to represent it by negative sign here. Then next term is what? Zero sequence component voltage and current value. So what is the zero sequence component voltage is given 20 at an angle minus 30 degree, 20 at an angle minus 30 degree into the zero sequence component current is how much? 3 at an angle minus 10 degree. So this time we want the conjugate of this zero sequence component, right? So this time the sign will get changed. So this is negative, we are going to change it to what? Positive. So that will give the conjugate of zero sequence component current. So this is what? 3 at an angle 10 degrees. So if you simplify it, so we are going to get the total complex power in this term. So where this first term represents active power, the second term represents reactive power, but we want in terms of per unit, right? So for that reason we need to divide it by the base value of the power. So the base value of the power is how much? 1 kVA. So the entire equation in terms of kVA we are going to divide it in to get in terms of what? Per unit. So this is the final solution for the given problem. Now let us solve another problem related on the complex power. So this is the problem statement for the next problem. It states as in a three-phase four-wire system. So it is having a four-wire system. The sequence voltages and currents are given. So respectively positive, negative and zero sequence voltage and current values are given. So from these values we need to find out what? The complex power in terms of per unit, and if the neutral gets disconnected, so we need to find the new power. So as it is a four wire system, so first we need to find out for the complex power for the four wire system, and suppose if the neutral gets disconnected, so that time it will become three wire system. So for that three wire system we need to find out the new power. So let us begin with the four wire system. So this is the equation to find out the four wire system. So the complex power is equal to respective voltage and current equation. So if you substitute respective values over here, and if you simplify it further, so we are going to get the voltage for 4 wire system as this much. Now suppose if the neutral gets disconnected, so neutral gets disconnected means the zero sequence component to current value will be equal to 0. So if we multiply 0 with the respective voltage value, it will become 0. So we are not going to consider the zero sequence component voltage and current values over here. So only we need to consider what, the positive sequence voltage and current, negative sequence voltage and current values. So if you substitute the respective parameters for positive and negative sequence voltage and current values, so if you simplify it further, so we are going to get the complex power in terms of per unit as this much. So the conjugate means whatever the sign we are having, we need to take opposite of that values. So keep that thing in your mind. This is the final solution for this particular problem. So if you have any doubt in this entire module, please feel free to ask. Thank you.